Each of two parents has the genotype brown-green, which consists of the pair of alleles that determine eye color, and each parent contributes one of those alleles to a child. Assume that if the child has at least one brown allele, that the color will dominate and the child's eye color will be brown. In part A, it says list the different possible outcomes and assume that these outcomes are equally likely. So the outcomes is either going to be brown or green. So the list must contain all possible outcomes. Since each parent can contribute either of their two alleles, the order of the alleles in their pair matters. So if we know that if they start out with the color brown, so we're going to label that as B, or we'll just say brown. So there's either a choice of the second here to be either brown or green. So one option is brown brown, and the other option is brown green. Now we also have the option of green, and that green can then have either a brown or green. So we have another option of green brown or another option of green. So that means we have a total of 4. Okay, so the possible outcomes are brown brown, brown green, green brown, and green green. So let's go ahead and check our results. So the list of the possible outcomes again are brown brown, brown green, green brown, and green green. Now the second part of the question is asking us what is the probability that a child of these parents will have the green green genotype. Okay, so recall that the probability of event A is the number of ways A can occur over the number of different simple events, which is another way of S over n. So in this case here, the probability of green green is equal to the number of ways green green can occur over the total number of different outcomes. Let's take a look at our sample space. We have one possibility of green green, so that means there's only one way of that occurring over the total number of different outcomes, which are 1, 2, 3, 4. So that's 1/4. And then as a decimal, that is 0.25. So the probability is either 1 out of 4 or 0.25. So the answer is that the probability that a child of these parents will have the green-green genotype is 0.25. The last question says, what is the probability that the child will have brown eye color? So taking a look at C, you would want to do the following. We're looking at, okay, what is the probability of a brown eye color? So that means what are the number of ways a child will have brown eye color can occur divided by the total number of different outcomes. Okay, well, let's come back up here. In the first scenario, we know that brown could be possibly chosen. In the second scenario, brown-green, we still have a possibility of brown being chosen. In the third possibility, between green and brown, we still have a brown possibility. And the last one is just green and green. So we only have 3 ways a child will have brown eye color can occur. So that's going to equal 3. And then again, we know that the total number of different outcomes is 1, 2, 3, 4 of our sample space. So that's 3 over 4, which then equals to 0.75 as a decimal. So our answer would then be the following. The probability that the child will have brown eye color is 0.75.